Okay, this is a review of the Unit 3 practice problems on intermolecular forces and properties. A few of these might seem like a review from Unit 2 on bonding, but there is some overlap when we talk about the states of matter and types of solids. All right, number 1, there are 3 substances studied in the lab, and the data in the table above were collected. Based on the data, which substances must have ionic bonding? Okay, well, we know things with ionic bonds have high melting points. All these melting points seem relatively high. But what else do we know about ionic bonding? Well, we know that as a solid, they don't conduct electricity. So that narrows it down to X and Z. Because think only things that are solids that are electrical conductors, that would be metals. Okay, so we know it's not Y. And then the last characteristic here is that the electrical conductivity in the liquid phase. Alright, so if an ionic solid is melted or molten, it has free moving ions, so it should conduct, so we would say high. So the answer here, I think, would be C. Yes, letter C. There's plenty of information to answer this question. Okay, so moving on down. Okay, number 2. We've got 3 different structures in the table, and we're asked which one had the lowest boiling point of the 3. So if it has the lowest boiling point, since these are all molecules, it's going to be with IMF. So let's take a look at the structures. So I noticed this butanol, we see a double bond O and a hydrogen. Pentane, it's just carbons and hydrogens. That tells me it's nonpolar. And remember, nonpolar molecules can only exhibit LDFs between their molecules. And then I look at propanoic acid, and I see that OH, which is the side of hydrogen bonding, plus that polar double bond oxygen. So butanol and propanoic acid both have polar qualities, which typically, since these are all about the same size molecule, are going to make them have stronger hydrogen bonding or dipole-dipole forces. So I think we will go with pentane. And we see a couple choices, B or C, so we need to see what is the correct reason, and we want to go with C. All right, number 3, moving right along. Which of the following most likely describes the solid represented in the diagram above? Okay, well, it looks like all the answers are descriptions of types of solids. So let's decide what kind of solid this is, and then we can find the answer that goes along with that. So the types of solids, we had atomic, molecular, covalent network, ionic, and metals. So which one of these does it look like? I see negatives and positives. Definitely looks like ionic. So A, soft, poor. Ionic compounds aren't soft, so we know it's not A. B, low melting point. Doesn't have a low melting point. C, brittle, water-soluble electrolyte. There's a good thermal and electrical conductor when molten. That sounds really good because D is malleable. That would be a metal, so we know it's not D. Moving right along, number 4. Which of the following best helps to explain why bromine is a liquid, whereas I2 is a solid when both are at 25 degrees Celsius? Okay, so this is properties that cause them to be different states of matter at the same temperature. We look at the 2 formulas and we should ask ourselves, these are molecules, are they polar or nonpolar? It's just 2 atoms bonded to themselves, no electronegativity difference, so we know they're both nonpolar. So that should help us decide that, and we know a liquid has weaker IMFs than a solid, and so since they're both nonpolar, we're only talking about LDFs, so we can tell that I2 must have stronger LDFs. So let's find the correct reasoning. It's talking about dipole moment. Well, they don't have a dipole moment. So C, I see the word London dispersion forces are stronger in BR2 than in I2. Does that make sense? It's a liquid and I2 is a solid, so that doesn't really go together. It must be D. London dispersion forces are stronger in I2 than in BR2 because I2 is a more polarizable electron cloud, and that is in fact the answer because I2 does have many more electrons, causing that more polarizable cloud and stronger LDS. All right, number 5. The diagram above depicts the Maxwell-Boltzmann distributions of 3 gases, neon, argon, and oxygen at 300 Kelvin. Okay, so they're all at the same temperature. Which choice is the correct identification for each gas? Okay, see, I'm thinking I need to look at a periodic table, right? So we need to look at the periodic table, and what do we need from the periodic table? We need to know molar masses, because if the temperatures are the same, the only reason gases have different velocities, because we can see that this gas is moving the fastest. I didn't really draw that very straight. B is in the middle, and A, doesn't matter if it's the tallest, the average velocity is the lowest. So which one of these has the smallest mass? Well, we can tell from our looking at our periodic table that the lightest gas would have to be neon, so it has the highest velocity, which is part C. So I'm looking and I see that C is neon. Well, it looks like that's what has to be my answer. Oxygen is intermediate as B because it's smaller mass, and then argon is the heaviest, so it must be A and move the slowest. So our answer is D. Number 6, which of the following best helps to explain why the value of delta H for the dissolving of sodium hydroxide in water is overall exothermic, which means it produces heat. Remember, this quantity enthalpy will be covered in Unit 6. What we really need to focus on is in a sodium hydroxide in water is exothermic. It gives off heat. That's the key right there. So what does that tell us? Remember, there are 3 things that happen when a solution forms. 2 require energy, and 1 process, the attraction of the ions to water. That ion dipole attraction is, if it's overall exothermic, must be extremely strong. So if we read through here, we can tell that D, sodium ions, have very strong ion dipole attractions with water, interactions with water. Remember, attractions release energy, breaking attractions takes energy, which is endothermic and would require an absorption. All right, number 7, a student is tasked with making 1 liter of 2 molar solution of potassium permanganate. The student only has an 8 molar concentrated permanganate solution, a 1 liter volumetric flask, and water to make the solution. Which choice will give the required solution? Okay, well, you can tell we're making a diluted solution from a concentrated, so this is going to be a simple math problem. So we've got our amount we're making, and I'm just going to drop the decimal places. We've got 2 molar, so that's like M1 V1, and we need to make 1 liter, and we know that our concentrated solution is 8 molar. In other words, I need to know how much do I need to, how much of that 8 molar solution do I need to put in the volumetric flask and add the water to dilute it. So basically I've got 2 over 8, so that's a fourth. And what's a fourth? It's 200 is 20, I'm thinking of milliliters, so a fourth of a liter is 250 milliliters. Okay, a fourth of a liter is 250 milliliters. So I need to find my right answer. So A, add 250 milliliters of the 800 milliliter solution to a flask and add water to the 1 liter line. That sounds pretty good. Add 400, okay, that's the wrong number. C, add 250 milliliters to 1 liter flask, water in the flask. So what's better, A or C? Definitely A, because it mentions the line on the volumetric flask, and D has the wrong number, so we're going to go with A. Number 8. A container with a movable piston is filled with 3 liters of air and a pressure of P. When the plunger on the piston is pushed, so the volume is 0.5 liters, what will be the new pressure, assuming the temperature remains the same? Okay, so we've got a volume and a pressure, so that's Boyle's law. You don't have to have numbers for everything, you can still work it out. So I'm going to put just P for pressure times 3 for volume. On the other side, it says we're solving for what will be the new pressure. So I'm just going to put a question mark because the writing of P again might be confusing. And I've got half a liter. So these would be multiplied. Okay, so I'm solving for my question mark, which is the pressure. So I've got to divide 0.5 to the other side. So 0.5 goes into 3 6 times. So my answer would be P times 6, which is answer C. Number 9, a sample of 0.1 moles of ethane gas is placed in a container at 273 Kelvin at a pressure of 22.4 liters. The ethane decomposes into ethene and hydrogen gas. What is the, ethine? What is the pressure in the container before the reaction begins? So I just want to know the pressure. So I've got moles of this gas, I've got a temperature, a volume. Sounds like PV equals nRT. So, I don't have a calculator, but I can still determine the pressure. So I've got 0.1 for N, and then the R is going to be 0.0. Make that a little bit better. 0.08. Now I'm not going to worry about the 0.08206. I'm just going to round. I don't have a calculator. I'm trying to make my life a little easier. Over and 22.4 liters. Now I look at these numbers, and I'm like, these numbers sound familiar. The molar volume of a gas is this volume 22.4 at this temperature, but it's for 1 mole. So if I have a tenth of a mole, the pressure should be 1 atmosphere. So if I have a tenth of a mole, shouldn't I have a tenth of the pressure? Yes. So the answer is B. So you don't actually even have to calculate that one. If you recognize that is part of STP, which is on the formula sheet, and then you recognize that this is almost what STP represents, but it's a little off, then we can just estimate the answer. Okay, look at number 10. Okay, number 10, the table shows formulas and molar masses for 3 different compounds. Which of the following would have the highest boiling point? Okay, we know molar mass, they're all about the same. That's not going to be a contributing factor. We really need to look at their structures. So looking at acetone, the C double bond jumps out at me, which makes this a slightly polar molecule. 1 propanol, the OH jumps out, that makes that a polar molecule, and then I look at butane and I can see nonpolar. So the highest boiling point is going to have the strongest IMFs between its molecules, so it's going to be, since all the molar masses are the same, it's going to be one of these. Which one of those is more polar and capable of hydrogen bonding? We're going to pick 1 propanol, and B is the answer. Okay, 11. At room temperature, chlorine is CI4 is a molecular solid. Which of the following provides a characteristic of CI4 with the correct explanation? Okay, think of molecules. Molecules are held together with IMFs to be a solid. Okay, so does it have a high melting point? Well, these two don't even go together. If it has a high melting point, it doesn't have weak IMFs, so there's no way those don't go together. It's hard because it forms a 3-dimensional covalent network. Well, they just told us it was a molecular solid, so it can't be both. C, it is not a good conductor of electricity because its valence electrons are localized in bonding and non-bonding pairs. That sounds like a Lewis structure, C is looking good, but let's double check with D. It is very soluble in water because its molecules are polar. Well, we know they're not polar. Ci4 would have a tetrahedral shape and be completely symmetrical. The dipoles would cancel and be nonpolar. So C is the best choice. 12. Based on the information in the table above, which liquid has the lower equilibrium vapor pressure? Okay, so it's not going to be based on mass. Vapor pressure is indicated by boiling point. So if it has a lower vapor pressure at 25 degrees Celsius, that means it has lower vapor pressures, mean they have stronger IMFs. So again, you can talk yourself through this. Low vapor pressures have strong IMFs. So which one of these two has the stronger IMFs? Well, it would have to be the one with a higher boiling point. So we can tell both of these are, this is linear and nonpolar, this is tetrahedral and nonpolar. So I want to pick C or D, and it has a higher boiling point because of C. It has stronger LDFs because it is a nonpolar molecule. Ready. 13. A vessel contains water vapor at a low temperature. Which of the following statements best helps to explain why the measured pressure is significantly lower than the pressure calculated using the ideal gas law? So we have a low temperature, so there's not a lot of energy there. If the ideal gas law is not working, that means water must be acting like a real gas. So let's think about that. There's really two things. It's either about volume or it's about intermolecular forces. So for 13, it doesn't really matter about molar mass for A or B. We're not breaking bonds when we're talking about water vapor. That's a chemical change, and this is just a gas. C, attractive forces among water molecules cause them to collide with the walls of the container with less force. That sounds really good. Water is polar. If there's not a lot of energy, they're not going to be moving very fast. They're going to get kind of drawn to each other and attracted to each other. D, the combined volume of the water molecules is too large to the total volume of the container. We don't really know anything about the volume of the container, and it's really mentioning the pressure. So the pressure is going to be affected by the molecules not hitting it. So C is the best answer. 14. Which of the substances listed above has the highest boiling point and why? Okay, well, we know neon's a nonpolar atom. It's only going to have LDFs. We know CH4 is tetrahedral, nonpolar LDF, so LDFs, LDS. If we drew C2H6, I'm just going to draw part of it. It's going to have two carbons. All these sticks I'm drawing would have hydrogens attached. That's going to be nonpolar. So all of those I marked out only have LDFs. And if we look at HF, it is eligible for hydrogen bonds. So B, it would definitely have the highest boiling point. All right, 15, another table. Based on the data in the table above, which of the following liquid substances has the strongest intermolecular forces? Strongest. So strong intermolecular forces, and again, notice this is about vapor pressure. Strong substances with strong IMFs have low vapor pressure. So we're going to pick D. All right, 16. Based on the strength of intermolecular forces, which of the following elements would be expected to have the highest melting point? So here, don't think it's not about what kind of bond, like triple bond, single bond, double bond, or anything like that. It's about, think about IMFs. If you look at all these, they're all nonpolar. They all have LDFs between their molecules. So which one of these is going to have the strongest LDFs, and hopefully you could even explain why if you're asked. So we want to pick the one with the most polarizable cloud, and what is that based on? The most electrons. So we're going to pick D for sure. Okay, 17. Which of the following substances involves the breaking of covalent bonds in order to melt? Well, I look at salt and I'm like, that's ionic. Sand, That's one of those special ones that was a covalent network solid, like a diamond. That looks like the answer. Let's make sure. Ice, well, I know water is a molecule. Only hydrogen bonds would be broken to melt that. Paraffin, I see only carbons and hydrogens. It's nonpolar. It's going to have LDF. So B is the best answer. 18. The relatively high boiling point of HF compared to the other hydrogen halides can be attributed to. Okay, so look at the formulas. We know all of these, are polar, mostly polar. HF is special because it can hydrogen bond. 19. Which of the following are intermolecular forces broken? Okay, carbon dioxide subliming, going from a solid to a gas. Carbon dioxide is nonpolar, is held together with LDFs. That seems like our answer. NaCl is ionic. Diamond, we mentioned a minute ago, is a special covalent network, only has covalent bonds, and that's a metal. So we definitely want to pick A. All right, 20, we have glucose, which is here on the left, and cyclohexane on the right. Select the answer stating which molecule is more soluble in water with the correct explanation. Okay, well, hopefully you're getting used to picking out all the hydroxyl groups, because anytime you see hydroxyl groups, those are places where water can hydrogen bond. I look at cyclohexane, and there are only carbons and hydrogens, means it's nonpolar. So hopefully it's obvious that glucose would be easier to dissolve in water, so we don't want to pick C or D. We look at A and B and see which one has the best answer. So does glucose separate into ions, which polar water is attracted to? No, this is a polar molecule, so it can't. That's what ionic compounds do. So it must be B. The oxygen and its molecules are attracted to with hydrogen bonding to the hydrogen end of water. That's definitely what's going on in the answer. Okay, another table. We've got structures and boiling points. Using the information above, choose the answer that correctly explains the higher boiling point of methanoic acid. Okay, well, look at propane, and it only has carbons and hydrogens. That means it's nonpolar. I look at methanoic acid, and I see two places that make it polar and where it can hydrogen bond. So, no question, methanoic acid has stronger IMFs, more specifically. So let's just look for the right. Methanoic acid has weaker IMFs. Well, that's not true because it has a higher boiling point. Methanoic acid has stronger hydrogen bonding among its molecules, which require more energy to separate than the LDFs among propane. Yes, very specific, and that is correct. Hydrogen bonding isn't weaker, and then covalent bonding really has nothing to do with it. So 21 is B. All right, 22. We have this iron 3 ion is mixed with thiocyanate ion and produces a red color. All right, that's going to be important. The spectrometer is used to measure the absorbance at 447 nanometers, and the concentration of the solution is calculated to be this molarity. What change would have to be made to analyze the concentration of an unknown solution of copper 2+ ion, which is blue? So different colors require different wavelengths of maximum absorbance. So if you read through, the only thing that's going to work is to have a different wavelength. 22 is C. Which of the following pairs of elements is most likely to create an interstitial alloy? So we need a larger metal atom and then something small, sometimes a nonmetal, sometimes a metalloid to fit in the gaps. So titanium and copper, aluminum, lead, silver and tin, magnesium and calcium. The best choice here is going to be B. Aluminum is a good bit smaller than lead. Okay, 24. Why does NaCl have a higher melting point than NH3? Well, notice from the formulas they're completely different substances. NaCl we know is ionic. NH3 is a molecule we draw a Lewis structure for. It is polar, and because of the elements it contains and the net dipole, it is able to do hydrogen bonding. So to me, I like to think about all these details and then I look for the answer. So, NaCl doesn't have LDS, network covalent, it's ionic, and then you get to D, and we went into more detail than needed, but we did easily find the answer. Okay, so now we have a chromatogram. If water is a solvent, okay, so remember we know water is polar, then which dye is most polar? Remember, the solvent is moving from the paper all the way to the front, or where it ended, okay? So which dye moved the greatest distance with water? And we see that for 25, that would be definitely C. C moved the greatest distance, therefore it was most attracted to polar water. 26 in the chromatogram above, what is the identity of the unknown dye? Okay, well we have to be careful here. Notice the solvent front did not move as far where the unknown is. So one way to look at it is, see how the unknown is like in the midpoint of where it started and where the solvent ended. So it's kind of in the middle. So which dye also is kind of in the middle of its chromatogram. So here's the origin. It doesn't look like B because it's a little low. A does look like it's kind of in the middle of that paper, so we're going to pick 26A. 27, which of the following best explains why the melting point of NaCl is lower than the melting point of calcium fluoride? Okay, well this goes back to Coulomb's law, right? The first thing we're supposed to consider for Coulomb's law are charges. So we see that Na and Cl are positive 1, negative 1. We see that calcium is positive 2, and then we've got 2 fluorides, which are each negative 1. So higher charges cause greater attraction between ions. We don't need to consider size of ions because we have a difference in charges. So we can see that it's all about the charge. So we need to find, it's not about reactivity, it's not about smaller, it's about charge. Okay, so make sure that when you're looking at Coulomb's law, charges should be considered first, and then if the charges are all the same magnitude, then you can move on to the size of ions. All right, 28 in the image above, what do the dotted lines represent? Well, there's an oxygen having an attraction to a hydrogen. That hydrogen is on a nitrogen. Let me check the next one. This hydrogen attracted to nitrogen. That hydrogen is bonded to a nitrogen. Hydrogen bonded to nitrogen. Those all look like hydrogen bonding for sure. 29. Which of the following most likely describes the solid? Represent the diagram above. The first thing I notice is the orange spheres do have a plus, so those are positive. But then those little yellow negatives, notice they're not evenly distributed. So we know it's not ionic. That's not a molecule, it's not a covalent network. That definitely looks like a metal. So which of these characteristics, because those variations in where those negatives are trying to show those free moving electrons. So which of these describes a metal? And we know D, malleable, excellent conductor. 30, what type of attraction is depicted between water and a calcium ion? Well, no question, this is ion and water is a dipole. B. All right, moving right along. 31, we have a 0.1 mole sample of krypton and a 0.1 mole sample of radon, both gases. They're placed separately in two 10-liter rigid containers at the same temperature, 25 degrees Celsius. Each container has a pinhole opening. Which of the gases, krypton or radon, will escape faster through the pinhole opening, and why? Well, the temperature's the same. They both have the same average kinetic energy, but their speeds aren't going to be the same. So that's what it's going to be based on. We need to look at our periodic table and molar mass. So if we look at krypton's molar mass and radon's, we'll see that krypton has a lower molar mass. We would expect it to escape faster. So we have to look and see, because it looks like A says that, B says that. Let's look at the reason. Krypton escapes faster because its atoms are moving at a higher average speed, or krypton will escape faster because its initial pressure. See, it has nothing to do with pressure. It has to do with the kinetic energy, and to maintain the same kinetic energy, a lower mass has to move faster. 31 is A. All right, 32. A stock solution of calcium chloride has a concentration of 4 molar. If 25 milliliters of the stock solution is mixed with 100 milliliters of water, what will the concentration of chloride ion be in the resulting solution? Okay, so we can tell, since we have a concentrated solution and we're mixing it with a lot of water, that it's going to be a dilution. So let's start there. So we have 4, and that's, since we don't have a calculator, I'm not using a lot of zeros. 4 molar times, we're using 25 milliliters of that, equals, and we're just solving for molarity here, and we'll make sure we need to address, because it did say specifically chloride ions. And then be careful, because if we had 25 and we add water to it, make sure this is a place that would be easy to make a mistake. That's the total volume is 125. So basically we end up with 100 divided by 125, and that's the equal to the molarity. So when we reduce that, and then we would get, a concentration of 0.8 molar. All right, moving on to 33. You have 2.2 grams of carbon dioxide and 4 grams of argon in a 1.25 liter container at 75 degrees Celsius. What is the total pressure in the container? Okay, these numbers are a little tough, so we can use a calculator. If this was an AP question, the numbers would be a little easier, but just making sure you can work through this math is important at this point. So for 33, notice it's asking for total pressure. There's really a couple ways you can approach this. Okay, since we have gases, I hope seeing volume and temperature and grams, hopefully that makes you think of PV equals nRT. And we really have a choice here. I mean, obviously we need moles. We can either solve each, change each of these masses to moles and solve PV equals nRT twice, like one time for each gas, to get the pressure of each gas and then add them together. Or, and this might be a new concept that works, you'll get the same answer, I just want to maybe show you a different way. We could take the mass of each of these, and this is carbon dioxide, so I'm going to divide by 44. That would give me the moles of carbon dioxide, which are going to be 0.05. And then I would do the same thing with the argon. So this part is the same. You have to do this math. The molar mass of argon is 39.95 for 1 mole. So 4 divided by 39.95 is going to give us 0.1. So my suggestion here is, instead of doing PV equals nRT twice, go ahead and add these moles together, and we can solve this. Just, you might not have thought of this before, but it's just in, a slightly different way. So we can solve for total pressure just by plugging in total moles. You can see it's really easy just to add those together. So we have 0.15 for our N. I'm kind of running out of room, so I'm going to kind of condense this, 0.08206, and then we have to change our Celsius to Kelvin, add 273, and it's going to be 348. So when you multiply all that together, Your grand total is 3.43, so we're going to pick A. All right, that brings us to the last two problems. What wavelength corresponds to a frequency of 8.22 times 10 to the 9th hertz? All right, when I see wavelength and frequency, I should think of the speed of light formula. Again, I'm not going to use, only that one problem is I can use a calculator. I'm going to try to not use a calculator here. So I'm solving for wavelength. So that means I have frequency, and I'm just going to drop the 0.22 divided by, and the speed of light is 2.998 times 10 to the 8th, but since we don't have a calculator, we're just going to round to 3. Okay, so you can see how this math becomes a little easier when you round the numbers. So basically, I end up with well, this is what happens when you don't show all your math. You make a mistake. So let me start that over because I just realized I rearranged it incorrectly. So basically, I need to divide the frequency to the other side. So wavelength equals the speed of light over the rounded version of our frequency. So 8 times 10 to the 9th. So basically I have 3/8, and then when we divide we subtract exponents. So I have 3/8 times 10 to the negative first. And so then I look at, this is when I don't like fractions, I look at my answers and I say, okay, well 3/8 is a fraction, okay, so that's going to give me 1 decimal place. I already have 1 decimal place from here, so I need an answer that starts in the second decimal place. That is my reasoning, and the answer is C. You could try on your calculator and you will get that. All right, and then the last one. Which type of spectroscopy would be the most useful in determining if a carbon compound contained a hydroxyl group in its structure? So a hydroxyl group is something attached. That's a functional group. We just have to remember which one, and hopefully you remember C.